Let's take a look at Wednesday's daily math. The first question, you are subtracting fractions, and we're looking for the model that correctly represents the problem. So remember, to add or subtract fractions, we first have to make sure that our denominators are the same. And if I look at all four of my answer choices, I have denominators of 9. So I know that I'm ready to subtract since those are the same. If I look at option 1, I have 4/9 minus 2/9. If I have 4/9 size pieces, 1, 2, 3, 4/9 size pieces, and I take away 2, which they've shown by crossing the other way, then I would have 2 left. Here's the 2 pieces that I have left. So I can see that they shaded incorrectly to begin with. They shaded 5/9 instead of 4/9. So option 1 is not correct. Okay, so we'll take a look at option 2. 5/9 minus 2/9. I have 1, 2, 3, 4, 5/9. So they shaded correctly that time. I took away 2 of them. That's shown by the lines going the other way. We can see that leaves us with 1, 2, 3/9. So that's not correct. Okay, looking at option 3. 5/9. Let's see if that's what they started with, the shading. 1, 2, 3, 4. I have 5/9 size pieces. I took away 1, 2 of those pieces, and that leaves us with 1, 2, 3/9. So option 3 is your correct answer. If I look on at option 4, I can see that instead of taking away 2/9, they took away 1, 2, 3/9. So even though the equation is correct, the model is not. Number 2 asks how many lines of symmetry the shape has. So we've got a shape with 6 sides. So that's going to be a hexagon. And remember, for a line to be a line of symmetry, it's got to be the exact same on both sides. I can think of it as being able to fold it at that line, and it would be a mirror image. It would look exactly the same. So if I take this, I could draw a line here from the opposite points, and I would have exactly the same. I could change colors each time, make it a little easier for us to count those here in a minute. I could do the same thing from this angle to the opposite angle. I would have the exact same thing. Could go from this angle across to the opposite angle and would have the exact same thing. I could also go from here to here, from here to here, and one more time I could go from here to here. So if we count the colored lines, we'll start with this light blue. There's 1, 2, 3, 4, 5, 6 lines of symmetry. So number 2, the correct answer is 6. This hexagon has 6 lines of symmetry. All right, number 3 is asking you to complete the missing information for the equivalent fraction and the decimal form of the fractions. So let's look at our model first. I can see I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 columns going across the top that are going up and down, and then rows across. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have a 10 by 10. If I multiply 10 times 10, that tells me there are 100 equal sized pieces within that square, within this model. And I could count those if I wanted to. So now I need to figure out what fraction is shaded. If I look, I've got 1, 2, 3, 4, 5, 6, 7 rows or 7 columns of 10. Each one of those rows has 10. That will be 70 squares that are shaded. We know in the whole thing there were 10 rows of 10. So there's 100 in the whole. So that fraction is 70 100ths. I can check that. I can also make an equivalent fraction to 70 100ths. If I took away the rows and I used each 10 for columns. Here's 1, 2, 3, 4, 5, 6, 7. I have 7 of those columns shaded. If I continue to count, there's 8, 9, 10 in the whole thing. So 7/10 is an equivalent fraction. I'm going to show you how we could prove that those two fractions are equivalent. I started with 70 100ths. If I divide both my numerator and my denominator by 10, 10/10 makes one whole. And remember, if we divide or multiply a number by 1, it doesn't change the number, the value that we have. So if I do 70 divided by 10, that equals 7. And 100 divided by 10 equals 10. So that proves that 70 100ths and 7/10 are equal or equivalent fractions. Now the second row asks me to find the decimal form. And for decimals in the tenths and 100ths place value, that's exactly the same. So I'm going to look for the decimal that shows I have 7 100th size pieces, and the decimal that says I have 7/10 size pieces. So if I had a place value chart, I'm just going to start it with the ones. You know what would be larger. After the ones place value, when we get to fractional or decimal parts, smaller than a whole, the first place value to the right of the decimal is the tenths place. And then next is the hundredths. Then after the hundredths, I would have the thousandths. Do you notice the pattern that's the same as numbers that are larger than 1? Using the same name, we're just adding the ending THS. Instead of tens, it's tenths. And instead of hundreds, hundredths, THS. Instead of thousands, I'm dropping the S and adding the ending THS. That tells me it's a part of a whole. So to put 70/100ths, there's the number 70. I would have 7/10 and 0 in the hundredths place value. So here is the decimal form of 70/100ths. We know if that zeros just hold a value. So if I took that 0 away, I still have the same amount. That's 7/10. So we would check that one. And for word form, just like regular whole numbers, we write the number just the way we say it. So we would have 70/100ths and 7/10. The next one, we're comparing the numbers 6/10. We have 6 shaded out of 10. Remember, this is the 10ths place. And then we have 27/100ths. There's 100 equal size pieces. I have 27 of them shaded. So I'm naming the number 27 and saying hundredths because that's in the hundredths place value. And if I just look at the amount that's shaded, I can tell that 6/10 is greater. And then for number 5, we're identifying the fractions on the number line. First, I'm going to look and see how many equal size pieces I have between 0 and 1. Between 0 and 1 is one whole. So I'm seeing how many equal size pieces there are. Between 0 and this first mark is 1, 2, 3, 4, 5, 6, 7, 8. So I can see that those are, the lines are breaking my whole number into 8th size pieces. I'm just going to go ahead and write the eighths in. I've got 1/8, this would be 2/8, then 3/8, 4/8, 5/8, 6/8, and 7/8. I have 3/8 as an option for B, so I can go ahead and mark B is 3/8. I have a 2/8 option for choice A, but I don't see 4/8 and I don't see 6/8. So let's look at finding an equivalent fraction for 4/8, which is C, and 6/8, which is D. What do you notice about 4 and 8? We can see that 4 is half of 8, so 4/8 is equal to 1/2. So C will mark 1/2. I can also look at my number line. I'm going to change colors here. If I go from 0 to 4/8, which is C, and then from C on to 1, it takes 1, 2, 3, 4 spaces to get there, and 1, 2, 3, 4 to get from C to 1 whole. So I can tell by that, that also proves that that is halfway. That's 1/2. And so I've gotten C taken care of, but I still have to figure out D. Looking at what we just did, let me erase these, make it a little less busy there. Looking from 1/2, do you notice that it looks like it's 1/2 again between C and 1, from C to D, and from D to 1 whole? Each one takes 2 spaces. So that would be, let's see if we can do the same thing back here on the other side. If I put 2 of my 1/8 size pieces together and another 2 together, those are all equal parts. So there's 1, 2, 3, 4 equal parts. And D is at that. There's 1, 2, 3. So 6/8 is equal to 3/4. We can prove that like we did on the model earlier. I can divide 6 and 8 both by 2. They both have factors of 2. This is where I told you factors were going to be very important when we started working with fractions. 6 divided by 2 is equal to 3, and 8 divided by 2 is equal to 4. So 6/8 equals 3/4. We can also prove 4/8 is equal to 1/2. Both 4 and 8 have factors of 4. So I can divide 4/8 by 4/4. 4 divided by 4 equals 1. And 8 divided by 4 equals 2. So 4/8 equals 1/2. We'll work a lot more with those fractions later, but I really want you to pay attention when we're using models to what these look like. That will really help you to visualize. Have a great day. Get all of your work done. And if you have any questions, you can add a private comment, send me an email, or have your parents send me a dojo message.